Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Today we're diving into a fascinating topic in our Advanced Synchronization Techniques chapter, ThreadLocal. Victor, are you ready to unravel this thread-safe mystery?
Absolutely, Sheila. I'm excited to discuss ThreadLocal, a powerful tool in Java's concurrency toolkit. But before we start, let's remind our listeners that we're in the synchronization utilities season, and we've just covered stamped lock and exchanger in our previous episodes.
Great point, Victor. Now, to kick things off, I have a quiz question for our listeners. Here it is. How can you achieve thread safety for a variable without using synchronization or locks? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Sheila. It might sound counterintuitive at first because we often associate thread safety with synchronization. I'm sure our listeners are scratching their heads trying to figure out how to keep data thread safe without the usual suspects like synchronized blocks or locks. It's definitely going to make them think outside the box.
Exactly, Victor. Now, before we dive deeper, could you give us a quick overview of what ThreadLocal is and why it was introduced?
Certainly. ThreadLocal is a class in Java that provides ThreadLocal variables. These are variables that are unique to each thread, meaning each thread that accesses a ThreadLocal variable has its own independently initialized copy of the variable. It was introduced to help developers avoid synchronization in certain scenarios where data needs to be thread-specific.
That's interesting. So if I understand correctly, it's like giving each thread its own personal locker to store data, right? But why would we need this? Can't we just use regular variables?
Great analogy, Sheila. And you're right to question that. We use ThreadLocal when we want to avoid sharing state between threads. Regular variables, when accessed by multiple threads, can lead to race conditions and require synchronization. ThreadLocal eliminates this need by giving each thread its own copy of the data.
I see. Can you give us a real-world example where ThreadLocal might be useful?
Absolutely. One common use case is in web applications for storing user context. Imagine a web server handling multiple requests simultaneously. Each request is processed in its own thread, and you need to keep track of the user associated with each request. Instead of passing user information through every method call, you can store it in a ThreadLocal, making it easily accessible throughout the request processing, without worrying about thread interference.
That makes sense. So how do we actually use ThreadLocal in our code?
Great question. Let's walk through a basic example. First, you'd create a ThreadLocal instance, typically as a static field. Then you can set values for the current thread and retrieve them later. Each thread that uses these methods will be working with its own copy of the data.
That seems straightforward, but I'm curious, how does ThreadLocal actually work under the hood to achieve this thread-specific storage?
Excellent question. Internally, ThreadLocal uses a clever mechanism. Each thread object has what we call a ThreadLocal map. It's essentially a special kind of storage where the keys are ThreadLocal objects and the values are the thread-specific data. When you interact with a ThreadLocal, you're actually working with this special storage in the current thread.
Fascinating. So it's like each thread has its own secret compartment for storing these values. Are there any gotchas or potential pitfalls we should be aware of when using ThreadLocal?
Absolutely, Sheila. One major consideration is memory usage. ThreadLocal variables are only cleaned up when the thread itself is cleaned up. In scenarios like thread pools where threads have a long lifetime, this can lead to memory leaks if you're not careful. It's a good practice to clear your ThreadLocal when you're done with it to prevent memory issues.
That's crucial information, Victor. It sounds like ThreadLocal is powerful but needs to be used judiciously. Are there any advanced features of ThreadLocal we should know about?
Indeed there are. One interesting feature is called inheritable ThreadLocal. It's a special type of ThreadLocal that allows a child thread to inherit the ThreadLocal values of its parent thread. This can be useful in scenarios where you create new threads and want them to have access to the context of the parent thread.
Wow, that's quite advanced. It seems like ThreadLocal has a lot of nuances. Before we wrap up, could you summarize the key points about ThreadLocal for our listeners?
Certainly. Here are the key takeaways. 1. ThreadLocal provides thread-specific storage, avoiding the need for synchronization in certain scenarios. 2. It's useful for maintaining context, like user information, throughout a thread's execution. 3. Each thread has its own copy of the ThreadLocal variable. 4. Be mindful of potential memory leaks, especially in long-lived threads. 5. Inheritable ThreadLocal allows child threads to inherit values from parent threads. Remember, ThreadLocal is a powerful tool, but it's not a one-size-fits-all solution. Use it when you truly need thread-specific storage.
Thank you, Victor. That's a great summary. Now, let's reveal the answer to our quiz question. How can you achieve thread safety for a variable without using synchronization or locks? The answer is by using ThreadLocal. Each thread gets its own copy of the variable, eliminating the need for synchronization.
Exactly right, Sheila. ThreadLocal provides a unique way to achieve thread safety by avoiding shared state altogether.
And that wraps up our episode on ThreadLocal. Next time, we'll be starting a new chapter on concurrent collections, beginning with an introduction to queues. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed the episode. Until next time, happy coding.